Hi guys, welcome to activity 5.9. This is your last activity for the semester. You made it. So this last activity is pretty much what we did in activity 5.8 with solving square root equations, but this is doing the same thing for cube root equations and fourth root equations. So we're going to go through just a little bit about each one, but we're going to focus mostly on how to solve an equation that has one of those, either a cube root or a fourth root in there. And you're also going to see some fractional exponents in here. And we're going to talk about why the domain of some functions is restricted, meaning I can't use everything for x, and some I can use whatever I want for x. So we start with a formula here for the radius. So a propane tank is the shape of a sphere, with r being the radius. V is our volume, and then pi obviously is a constant. So this just came from a volume formula. If you look up the volume of a sphere and then you solve it for r, this is what you end up getting. So all they did really here was they took a volume formula and solved it for the variable r instead. Okay, so we're going to find a couple things for this. So what is the radius of the propane tank having a volume of 50? Okay, so they already solved it for r, so we're ready to use it. And we're just going to plug in, so the cube root of 3 times 50, I'm just plugging in that 50 for r. Sorry, my handwriting is bad on this today. I bet you would have thought they would have gotten better over the course of the semester, huh? But, all right, so if I do that out in the calculator and round to the nearest tenth, I get about 2.3. Okay, so there is a cube root. Most calculators have a cube root button above the square root possibly, or it sometimes is under another menu. But you're going to see an easier way to do it. If I have to do, I'm going to go over on the side here. If I have to do, say, the cube root of 8. Now I know that comes out nice and whole, so I probably don't have to use the calculator. But if I can't find that cube root function, this is the same thing as 8 to the 1/3. And that's easier to do on the calculator, but I would have to put this in parentheses if I were doing it like that. All right, so back to this volume problem. So I already filled in that they want us to fill in the radius for certain volumes, 0, 5, 10, 15. So I filled all those in. I plugged them into that radius formula, and I found them. And then I graphed them. Okay, so take a few minutes, stop the video, and you do that part, and then catch up with me. Okay, so now we're looking at different roots. So we've looked at where this doesn't have a little n, so we know it's a square root. Okay, so we're looking at for other roots. So consider the cube root function, so just a plain old cube root of x. What's the domain? So we have to ask ourselves, can we take the cube root of any number? Okay, it doesn't always have to come out whole, but my domain would be all real numbers, because I can take the cube root of anything. This is never going to be undefined, okay? Different than a square root. A square root, what's under the radical has to stay positive. So now let's look at, I did this part ahead of time too. So that graph that we looked at kind of looked like a square root, but that's only because the one before we were only graphing for positive volumes. I only had volumes from 0 to 100. So it's actually not a square root function. It looks different. The square root function only is defined for part of it, so it doesn't go on forever. If I plug in all these x values into that same volume formula and get a radius out, or actually, I'm sorry, they're not using the volume formula here. This one we're only using this one. Just a very basic cube root of x. But the other function would look just like this one. You see that this graph, so again, fill out this table and graph your points, and you'll see that this graph goes on and on forever in both directions. So that kind of shows me right there that my domain is all real numbers, because this graph doesn't end in either direction. Okay, is this one increasing or decreasing? So this one right here is increasing. They don't always have to be increasing. It depends on if there's any negatives going on in this function. So then you can look at these, and it's showing you, okay, so it's actually coming back to what we just said, how to graph this on the calculator, and see, you can use the cube root right here, okay, or you can write it as x to the 1/3. They're the exact same thing. So play around with doing, looking at these different methods and number 3 on the calculator. All right, so part of this I'm actually going to cut out. I'm going to do 4a, because that I think is very important. But we're not going to get too much into some of these functions. But I do want to show you that these functions are really inverses of each other. They do the opposite thing to x. But for both of them, x to the third, I can plug in anything I want for x, and I can cube any number I want. And I can take the cube root of any number that I want. So the domain of both of these are all real numbers. So neither domain, what we say, neither domain has any restrictions. So this part B, I crossed it off because I know you can plug all those values in, and if you want to just take a look at these two functions on your calculator, you can see that they're inverses of each other. They do the opposite thing, and their ordered pairs are inverses. But that's just kind of an extension of what we're trying to do here. So let's see what else I want to do here. I did want to jump down to number 5, and I'm not going to do 5a because at this point you have done these so many times with these tables and plugging in. I know you can do that. But I do want to look at the domain of f and g. So let's specifically do f. And if you have trouble with this, you may want to plug in values for that table to see what's happening. But I'm going to just compare these. And I'm going to start with actually the g of x. So we have to find the domain of this one that's a fifth root of x, an odd root, which means that's going to behave very much like a cube root. So the fifth root of x, for that function, I can plug in anything that I want. I can take the fifth root of 1,000. I can take the fifth root of negative 1,000. We're not saying it's always going to come out nice and whole or even positive, but it will always be real. So this domain is all real numbers. Okay, back to f of x now, this fourth root. This one is going to behave very much like a square root. And we know that a square root of x is not defined for everything. And the fourth root is the exact same thing. This piece right here has to stay positive or greater than, or it can be 0, but it has to stay greater than or equal to 0. So x minus 1 has got to be greater than or equal to 0. Which means x has to be greater than or equal to 1 on this one. So that's my domain for this one. So you're going to see any even root, when I'm doing, and that's even, my domain's restricted. But if I have an odd root, this graph goes on forever in both directions, and my domain's not restricted. So that part I just did want to show you. All right, so now we're going to focus. So let's come up here. I crossed off part C. You don't have to worry about that. And example 1 here is going through this with you, okay, showing you, well, we did the same problem before with a square root. So for a cube root, the only difference is once I isolate my cube root, like let's say I'm right here, I've got my cube root alone, I have to undo a cube root, so I'm going to cube both sides. So it's very much the same, but I want to do a couple examples with you, both in this video and I have one more other video. So let me see if I can find one. I'll let you step through that one, and I'm going to cover the next one. All right, so now we're coming back to the very beginning example that we had, okay? So we had, remember, the radius was the cube root of 3v over 4 pi. And now they're telling us write an equation to determine the volume of a spherical tank that can fit into a given space. And let's see, the propane tank is, okay, so the diameter of it is 10. Okay, so the max radius, they're saying, is 5 here. Okay, and we're trying to figure out what is the volume if the max radius is 5. So I'm plugging in 5 for r, for my radius. And now I have to solve this. I've got to solve this for v. So I have a cube root, and my cube root is alone right now. So I'm going to start trying to undo that cube root. I don't have to add or subtract anything to both sides because the cube root is already by itself. But what I am going to do next is I'm going to cube both sides. And then I end up getting 125 equals 3v over 4 pi. And now I have a nice equation that I can solve for v. I multiply both sides by 4 pi. and that's gone there. So let me just draw a little line here. At that point, I have 500 pi equals 3v. I divide out to 3. So that's my exact answer. If it's in terms of pi, that's my exact answer. If I do this out using plugging in pi, the value for pi, I get about 523.6. And let's put a unit on this. This would be cubic feet or feet cubed, because that's what a volume is in. Okay, and then they're showing you how you could do it on the calculator by just plugging this right here. This line is the line y equals 5. And then this line right here is the y equals cube root of 3v over 4 pi, and you're going to look to where they're intersecting, just like you've done many times here. Okay, so let's come down to this last one right here. We'll do a couple parts of this together. Okay, so the basal metabolic rate, the number of calories per day a person needs to maintain life, okay, and that's based on their weight. And so W is their weight, and B is their BMR. Okay, so write an expression, this expression right here, which is at the right-hand side of this, using fractional exponents. So that might be new to you, but this right here using fractional exponents, the cube stays the same, still looks like W cubed, that won't change. But for me to take a fourth root, I have to have a 4 in the denominator. So this right here would be that one in fractional exponents. So the first thing they want us to do is, let's say W is 50. So they're just having us find what is the BMR if your weight of 50, and this is in kilograms. So this is not hard because I'm not solving anything, I'm just plugging in. And if I end up doing that out, I get 1,116 calories. Okay, but the main thing is, well, I'll let you do part C because that's putting your weight in, but I want to look at part D, where they give us the calories to fill in, and they want us to go back and find the weight. So here's where it becomes into an equation that we have to solve. So now, if something's raised to the 3/4, okay, the way I'm going to undo it, well, first I'm actually going to get rid of this 70. Okay, because I want to, I'm going to leave it just in fraction form for right there. So I've got 2,000 over 70 equals W to the 3/4. So if something's raised to the 3/4, for me to undo it, I would have to raise it to the 4/3, which really means taking a number, taking its cube root, and raising it to the 4th. Okay, but if you do this out and do this fraction raised to the 4/3, you end up getting about 87.3. Okay, and that would be in kilograms. That's what someone's weight should be in order to be able to maintain, to consume 2,000 calories. So if you look at the next slide one, but the top of this slide is doing the work for that part. And then you have a summary. Okay, but I'm going to more, the next video that I give you, just a nice short video, is going to focus on this part, just taking a couple more examples and showing you how to solve those. So I think that will help you with that.